Welcome back to Diagnosing Locking and Blocking. So what is blocking? Blocking is what we just saw in the demonstration in the prior video. Blocking is what happens when a user attempts to access some record or object within the database that another user has an exclusive lock on. Now, when users complain about this, they're not going to complain to you that they've got blocking problems. What they're going to see is basic slowness in the application. They're going to click on something, they're going to expect a result to happen right away because it normally does, but on occasion it doesn't. This is what you're going to get reported to you as the database administrator. What's actually happening under the covers, most likely, is some sort of blocking by either another user or a background system process or some service that's touching the data as well, making large modifications. We resolve blocking by resolving the cause of the blocker. This is done by typically adding indexes, rewriting the queries that are causing large locks to be taken, or by just simply putting faster storage on the storage subsystem. Maybe we're not able to get the data we need fast enough, so we're taking locks for longer than we want, or we need more RAM so that we can cache data for longer, and therefore not need to wait for our storage to give us data. Identifying blocking is actually fairly easy. We can simply run the sys.dm_execute under request dynamic management view, and we can look for the blocking session ID column. This is going to tell us who's doing the blocking. Basically, anything that's got a value other than 0 is a session being blocked. Now, the exception to that is if the blocking session ID is equal to the session ID. This means we've got a parallelism problem, not a blocking problem. Let's go ahead and take a look at blocking and see exactly how we can diagnose this. So we've got the exact same instance, we've got the exact same queries from the previous video. So let's go ahead and begin a transaction, and let's go ahead and insert a new record. Now our transaction is open even though our query is completed. So let's go ahead and run our count again. And as you can see, we've got the exact same locks being taken before by both of these processes. So let's go ahead and take a look at sys.dm execute requests. As you can see, there's a lot of information being returned here. We know what sessions we're looking at, so let's go ahead and specifically only look at those sessions. Normally, obviously, you'd need to diagnose all the data in here to see exactly what's going on. But in this particular case, we don't need to worry about that because we already know what sessions we want to dive into. We know that session 52 is being blocked. So let's go ahead and take a look at who's blocking that. We can see the blocking session ID is session ID 55. We can see the wait type that we're waiting for is a lock MS. This is telling us that we're waiting for some sort of modification to happen. We can see the wait time is 42,000 milliseconds. So this was running for about 42 seconds when I actually ran my query against DM execute requests. We can see the specific resource that I'm waiting for. We can see I'm waiting for a RID lock on database 9, file 1, page 24888, row 1 within that page. We can see that this particular session does not have an open transaction and that we are waiting for a result set to come back. We're waiting for a single result set. We can get some information about a transaction. If there was an estimated completion time and a % complete estimate, we would see those as well. Typically, those are only going to be shown for things like backups and restores. We can see what scheduler we're waiting on, how many logical reads there have been, and then some various information about the session that we're looking at. So there's a variety of ways we can see what query is being run that's causing our blocking. We can use the DBCC input buffer. We can look at execution sessions. We can look at the plan cache. There's lots of ways we can do this. I'm simply going to use DBCC input buffer and specify that I want to see what's going on for session 55, because this is the session that's being blocked. I can see in the event info the command that I'm running. I'm doing an insert. Now I can then use dbcc open_tran to give me some information about the longest running session, which in this case is session 55. I can see that it's a user session, I can see who started it, and I can see that it's simply just sitting there idle. The reason I can see it sitting there idle is because the session isn't currently running. if the command was currently running, it would show up here in sys.dm execute requests under session ID 55. So this means I know I've got an open transaction that's just lagging for some reason. Either the user's not doing anything in the application and the application's got a transaction bug in it, or in this particular case, the user's got a session open with an open transaction. We commit the transaction, we query DM execute requests, we have nothing else listed there. We look at the input buffer for 55, we see that we've got a commit as our last transaction that session has run. We can look at OpenTran and see that we have no open transactions in the system. So in summary, locking is how SQL Server ensures that one user and only one user is changing something at any one time. We don't want long-running locking, but locking necessarily by itself isn't a bad thing. When locking potentially becomes a problem is when it starts causing blocking, because that's when our users are going to start seeing something. What we want to resolve is the cause of the extended lock, not the fact that locking and blocking is happening.